professional development meetings. It's just watching this sport on YouTube. Sorry. Keep taking for the team. There's all the light coming in anyway. All right, so again, sketch one period of this guy right here, okay? So let's just go through this left to right. Gosh, probably should throw up the. Let me throw up the parent graphs real quick. Let me throw up the parent graph of sine. Sine starts at the origin. Remember that. Okay. Sine starts at the origin. This is f of x equals sine of x. Sine, right? When you're drawing a sine, one period of sine, you start at 0. Okay, y equals 0. Go up, okay, down, back up. Right? This is 0, 0. My period for sine is what?
2 pi.
So what's this x going to be? 2 pi. Right here, smack dab in the middle, right? That y coordinate is what, since I'm right on the axis? 0. And then what's that x coordinate? Pi. Smack dab in the middle. This has a y coordinate of what? -1. The x is what? 3 pi over 2. Okay, good. So sounds like we're catching on. This would be what, pi over 2? So there's the parent graph, okay? Here's the parent graph, okay? Let's talk about this +1 first. What's that +1? So, right, we're going to start from our parent graph, okay? And then these different numbers that we added in are going to shift my graph around. What's that +1 going to do? It's going to slide the whole thing up 1, right? So instead of drawing my squiggly around y equals 0 here, right, I'm going to draw my squiggly around y equals 1. Okay, it's going to bump it up 1. Okay, so I'm going to draw it around that line right there, y equals 1. Sweet. Good stuff, okay? Now let's think about what this plus pi over 6 is going to do. What's that going to do to my graph? It's going to slide it to the left by pi over 6, okay? So what's going to happen at this point? This point got slid up 1, and it's going to get slid to the left by pi over 6, right? So that point right there, that first point on that period that I'm going to draw is going to be minus pi over 6, comma, 1, okay? We start at the origin, we got slid up 1, left pi over 6. Okay. Okay. Then, what is this? So we can, at this point, we can actually draw. We can draw the curve right here, but we need to do what first? So let's make note of one thing. There's a minus here. What is that minus going to do to my graph? It's going to flip it, right? So instead of like drawing a hill and then a valley, I'm going to draw a valley and then a hill. Okay, so I draw a valley and then a hill. Okay, yeah. So there we go. Okay, and then the negative did that. Yep. This y coordinate here is going to be what on this last point? So the same still, right? It's the same as that first point. So I'm going to have a y coordinate of 1. On the right, okay? All right, how do I figure out what that x coordinate's going to be? What do I have to look at now? Yeah, I got to look at the period. I got to figure out what the period's going to be. What's my period? And how do I know?
3 times 2 pi.
Close. So the 3 is going to have something to do with it. We do 2 pi over that 3. So my period is going to be 2 pi over 3, okay? So if I start at minus pi over 6, and I slide to the right by 2 pi over 3, let's figure out what x coordinate that is. Okay, so I have minus pi over 6 plus 2 pi over 3. All right, we're scared of adding fractions when we have pi, and that's okay because we can ignore the pi. We can just do -1/6 plus 2/3. Right, that's -1/6 plus 4/6, which is 3/6. Okay, so then going back to the pi's, that's just 3/6 pi. Okay, I'm going to leave it like that for now. Okay, so this is going to be 3 pi over 6, comma 1. Right? And this point, smack dab in the middle, right? It's on that dashed line, so it's still going to have a y-coordinate of 1. Smack dab between minus pi over 6 and 3 pi over 6. We can, I don't like do, so what you can do when you're trying to like answer the question of what's smack dab between these two numbers, we can do what? We can add them together and divide by 2. So I want to know what's smack dab between minus pi over 6. Well, okay. I want to know what's smack dab between -1/6 and 3/6. I can figure that out by doing what? I can just add them together and divide by 2. Okay, so that's going to be 2/6 divided by 2. Dividing by 2 is the same as doing what? Times 1/2, right? So 2/12. Okay? 2/12 is the same as 1/6. Okay? So right here, this point smack dab, this point right here smack dab between minus pi over 6 and 3 pi over 6, that's going to be 1 pi over 6. Okay? Is that okay? And then right here, smack dab between minus pi over 6 and pi over 6. Would that be 0 pi over 6? Okay. I'm not the best drawer. That's okay. Look at that technology. So right here, it's going to be 0, comma what? 0, comma what? What's going to be the lowest y value I have? What's that? For my parent graph, it's -1. What do we notice up there that might change the amplitude? It's the 2 right here. The number that multiplies everything right at the front. That's going to be my amplitude. So my amplitude here is 2. My amplitude is 2. So what is this y-coordinate going to be? It'd be negative. Okay, so it would be negative. The amplitude's -2, but the middle, so the amplitude is going to be the distance between this dashed line and that bottom point there. So it's going to be 1 minus 2. -1. -1. So it would be -2, but my whole graph got shifted up 1. Does that make sense?
Yeah.
So then at the top here, this point right here, what's that y-coordinate going to be? So we started right, my y start at 1, and then it gets jacked up 2 to get to this peak. So that's 3. So to get the y-coordinates, what you really have to do is like add these two together. Or subtract.
Can you say that one more time? How to get it one more time? How do we get it again?
Yeah, so to get these two y-coordinates here,
Yeah.
you start with 1.
Okay.
You do the green number, and I need to highlight that. You do that green number, let's do purple. Do the green number 1 plus or minus that purple number.
Okay.
Right, so 1 plus 2 is giving me my y-coordinate up here of
Yeah.
3. 1 minus 2 gives me my bottom
That
y-coordinate.
makes sense.
Yeah. Yeah, my amplitude's 2, right? So the peak is a distance of 2 from my center line. The trough. My peak is a distance of 2 above the center line, but the center line's like shifted up 1. Okay. Subtlety. And then what's that y-coordinate there? Or x-coordinate, sorry, right here. You guys got it.
2 pi over 6.
2 pi over 6, yeah. There you go. So that's the period. What was my phase shift? So just filling out these spaces. Left, pi over 6. My vertical shift was what? Up 1. And then for frequency, you just flip over that period. All right. Doing okay? Good stuff. Good stuff. Okay, move on to the next. So let's skip that for now since we had the video notes, and I also want to make sure we get through everything. We've just got a few more things to do down here. It's not too bad. We should be able to finish this today, actually, I think. So now we're going to talk about the parent functions of tangent, cotangent, secant, and cosecant. Okay? So we're going to talk about those. So I'm going to start actually by drawing the parent graphs of sine and cosine. I already have sine over there. Okay. For drawing a period of cosine, I start where?
1.
I start up 1, right? I go. Okay, then when I get back up to positive 1, that's 1 period, okay? All right, what's this? So this is going to be 0, 1. What's this point here? What's the period of my cosine?
Is it also
2 pi, yep. Sine and cosine both have period 2 pi. All right, smack dab in the middle of them, that's pi, right? Pi negative 1. Smack dab between 0 and pi is what? 1/2 pi, yeah. Yep. And I'm just going to put, I'll do the whole point. Smack dab between pi and 2 pi. 3 pi over 2. Okay. So that's my parent graph for cosine. And actually what I'm about to do is I'm going to replace these with a dashed line. You'll see why. So I'm just going to replace these solid lines with a dashed line. You can use a lighter color on your notes if you want, okay? So these are the parent graphs of sine and the parent graph of cosine, right? But we want to draw parent graphs of secant and cosecant. So if we're trying to draw, let's call this g of x. Let's start with cosecant over here. Do you guys want me to turn on more lights or no? So what is cosecant equal to again?
Inverse of sine.
The multiplicative inverse, 1 over sine, yeah. What you said is correct, but there's multiple different types of inverses. So it's 1 over sine, right? Okay. So if we're trying to graph 1 over sine, we're trying to graph the reciprocal of this function, right? Notice there's 3 points here where sine equals 0, right? Where sine gives a y-coordinate of 0. So at those points, what's cosecant going to be equal to if sine is 0? At these 3 points, my sine is 0, so my cosecant is going to be 1 over 0, right? That's going to be undefined, right? So I need to draw 3 vertical asymptotes at those points. Okay. All right. So I'm going to have a vertical asymptote at x equals 0. I have another vertical asymptote at x equals pi. And I have another vertical asymptote at x equals 2 pi. Right. Let me change where I write these points. Pi over 2. So are we good on the why there's asymptotes there? Okay, so that's where sine equals 0, so cosecant's going to be undefined. We've got to have asymptotes there, just like we did for rational functions. All right, and you get the reciprocal of sine, you get cosecant by flipping over sine, right? You flip over the sine, flip sine over. So you're going to get the graph of cosecant by taking, look at these two dashed red lines here. You're just going to flip them over, okay? That's your graph of cosecant. You just flip those two guys over. So that's it right there. So if you guys want to draw that in, so we have asymptotes at 0, pi and 2 pi. There's a right side up parabola right here. Okay, and that point, it's going to be the exact same point as this first peak on the sine function. So it's going to be pi over 2, comma 1. And this will be 3 pi over 2, comma negative 1. All right. So literally, the different parts of our sine graph just flipped over. Okay. My period here is what? What do you think it's going to be? 2 pi. Yep, so the period is the exact same, right? What's my amplitude? There isn't an amplitude. There's no amplitude.
Why?
So amplitude is defined as the distance from like your center line of your graph to like the peak or to the valley. There's no peak or valley because it goes down forever and up forever. Yeah. So that's the cosecant graph, guys. It's just a bunch of parabolas that alternate forever. Okay. How do you guys think I'm going to draw my cosecant graph? Or my secant graph? Where am I going to have asymptotes here? Where do I need to draw my asymptotes for the secant graph? Yeah, so wherever y equals 0 here, right? So secant, right, that's 1 over cosine of x. So wherever my cosine graph hits 0, my secant graph is going to be undefined. So I need a vertical asymptote at those 2 points. So I get x, this is x equals pi over 2, x equals 3 pi over 2. All right, and I'll slide Mr. Thinnacle's stuff over. Sorry, Mr. Thinnacle. Okay, let me rewrite these points. Pi, comma, negative 1.
So the asymptotes are x equals 0. No,
X
y
equals pi over 2 and x equals 3 pi over 2. So I drew them right through wherever my cosine
is 0.
was 0, I had to draw a vertical asymptote for secant. Because 1 divided by 0 is undefined. It's not a number. It's not defined. It's not defined. Sad. One of the greatest disappointments in life. Okay, and then what do you think I'm going to do for this one? Just, all we did for sine, right, was we just flipped over. We just flipped these two guys over. What am I going to do over here? Yeah, so I'm just going to take this red line here. I'm going to flip it. Okay. Take the blue, take this red guy, flip them. All right, and then right here we're going to flip. There you go. That's secant. Okay, the points are all the same. All the same points. That's secant. It is, yeah. So cosecant and secant are just a bunch of alternating parabolas. So I'll do that in orange. So we're going to have asymptotes at x equals pi over 2, x equals 3 pi over 2. And then we'll have and then all the points are the same. So this asymptote is x equals pi over 2, x equals 3 pi over 2. This is 2 pi comma 1. This is 0 comma 1. Okay, so what's my period for secant? 2 pi. We're still 2 pi. What's my amplitude? Still no amplitude. Empty set. That looks more like a phi than empty. Let me draw that better. There you go. So that's your cosecant and secant parent graphs. Those are the parent graphs. Okay. Can I move on? You guys okay if I move on? Let's move on. Zoom back into secant. Yeah. I'll zoom. Yeah, you guys copy that down. I'm going to erase these real quick on the board.
How far are we gonna, like, how many sections are we gonna test?
Through we're going to do like a little bit of 4-5. Mostly it's going to be 4-1 through 4-4. Miss White said like she doesn't hit 4-5 too heavily. She'll say like she said something like she'll give you like a picture of one of these graphs. You'll just have to say like what graph it
If
is.
it's like, so she'll show us like one of those.
Be like, what is this? And you have to be like secant. Yeah.
Oh, okay, so we won't have to draw that.
She made it sound like no. That was my impression from when I just spoke to her.
Okay. And then the other ones we'll have to draw?
Yeah, sines and cosines you need to know how to draw. But you guys can do it.
Are we skipping tan?
No, we're not skipping tan. We're about to do that right now. I would never skip tan. All those tuition dollars. Let's talk about tangent. Let's draw one period of tangent. Let's talk about tangent. I need to check my work. Yep, that's what I thought. Okay, so this is what a period of tangent looks like. It's pretty straightforward. So tangent is equal to sine over cosine. All right, it's equal to sine over cosine, right? And that comes from the fact that when we're looking at the unit circle, tangent of theta equals y over x, okay, which is sine over cosine. Right? If I'm looking at a coordinate on the unit circle, the x coordinate is cosine, the y is sine. Okay, the sine of that angle. So I just want to tell you guys that for conceptual background to explain why, right? Whenever cosine is equal to 0, what's my tangent going to be? Undefined, right? So at minus pi over 2, okay, and at x equals pi over 2, positive pi over 2, my tangent graph is going to have asymptotes. Other than that, right here at the origin, my tangent is going to pass through the x-axis, and it's what we call an increasing graph. So it really just looks like a little squiggly. It looks like a little squiggly that goes up through the origin, and it has these two asymptotes here. That's a period of tangent, okay? One thing that's really important to note about tangent is that it's increasing. What do I mean by increasing? As I go from left to right, what direction is my hand going in? It's going up. Okay, so tangent is increasing. Very important. Okay, so we're going to have asymptotes. Now, x equals minus pi over 2. X equals positive pi over 2. We go to the origin. What's the amplitude of my tangent, given what I told you about secant and cosecant? There is none. There isn't one. It doesn't exist. Tangent does not have amplitude. What's the period of a tangent? Who said pi? Yes, it's pi. Yeah. How'd you get that? Where'd that number come from? Yeah, so the space between the asymptotes, right? Pi over 2 minus pi over 2 equals pi. And it's pi over 2 plus pi over 2. All right, so that's it for tangent. So the tangent graph, if you graphed on your calculator, it's just a bunch of these over and over and over again. Okay. Make a little dance. Hit the tangent. So the cotangents, it's almost identical. It's very similar. So if we're going to graph cotangent, cotangent equals cosine over sine. And I just tell you that to give you some conceptual background as to why there's going to be asymptotes on the cotangent function. The cotangent function is going to have an asymptote wherever what equals 0. We're going to have an asymptote, wherever sine is 0, my cotangent is going to be undefined. I'm going to have a vertical asymptote, okay? So I'm going to have vertical asymptotes here. And so at x equals 0 and x equals pi, I'm going to have vertical asymptotes, okay? My function will intersect the x-axis right smack dab between x equals 0 and x equals pi. So what's this coordinate right here, guys? Pi over 2, comma 0. Yeah. Okay. And then the only other difference about cotangent graph is that it's decreasing. So my squiggly is going to start at the top left and go down. Okay. You guys see how I'm decreasing? Right, as I move my hand from left to right, it's going down. So that's cotangent. That's cotangent. Sorry. So that's cotangent. What's the amplitude of my cotangent? It doesn't exist. What's my period? All right, so that's all of it for the trig graphs. So those 4 parent functions. Any questions? Any observations? Notice and wonder. Notice and wonder? Let's go down and do these. So we're going to skip all these. Miss White said she skipped all these. Okay, solve, no calc. X between 0 and 2 pi. All right, I feel like we've already done ones that are kind of similar to these, right? We did with sine, cosine, and tangent. Yeah, we did. Hundo P. Sorry. We did it back in 4.3, I think.
Probably.
It's all good. So I'm going to draw my little coordinate axes, my little unit circle. So let's draw my coordinate axes with my unit circle. That's my best friend. Let's get out my special right triangles handouts.
You can't use that on the test, can you?
No, but it's pretty easy to memorize how to draw them. Just make your own. I'll talk to Ms. White about it. So let's avoid radians. All right, learned our lesson there. All right. Let's just, if they want the answer in radians, let's work in degrees and then convert to radians at the end. Are you guys okay with that? What do you multiply to convert from degrees to radians? 180 over pi, right? That's your best friend. That number's your best friend right now. Okay, let's fill in these coordinates. Real quick review right here. Why am I filling in these coordinates on this unit circle here? Real quick review. When I have a question on the quiz or test that's asking for the sine, cosine, or tangent of one of these angles, one of these 4 angles here, what do I look at? Which one's the cosine? What number on this board is the cosine of 180? It's the x-coordinate of this point right here. So cosine of 180 is -1. All right, which one is the sine of 180? 0. And how do you get the tangent? You divide the y over the x. Okay. Yeah. And then if they give it to you in radians, yeah. Be good? A little review, a little quick review. All right. All right, let's get our special right triangles out. There it is. I'm going to draw them for myself. Oh, I got to put Cam's little whiteboard back up here for him. Here you go, Cam. So let's draw these. I'll draw them in degrees. 45, 45, 90, 1, 1, root 2. All right, these will be your best friends in life. These 2 triangles. 60 degrees, 30 degrees, 1, root 3, 2. All right. Let's get to it. Secant x equals 2. Secant x equals 2. Who prefers working with secants and cosecants as opposed to sines and cosines? Good. I do not expect to see any hands. So what can we do here? to change secant to what? What can we change secant to? Yes, 1 over cosine of x equals 2. Equals 2. So let's solve this for cosine first. So if you solve for cosine, you get cosine x equals 1/2. Okay? Right? So if we want to solve for x, right, we got to hit both sides with inverse cosine. So we get that x equals cosine to the -1 of 1/2. Cosine to the -1 of 1/2. How do I say that phrase in English? Cosine to the -1 of 1/2. Yeah, so the angle whose cosine is 1/2. I'm looking. What's that? Okay. Now I want the angle whose cosine is 1/2. Okay, so let's look at my special right triangles. What angle on there has an adjacent of 1 and a hypotenuse of 2? 60. So I'm really interested in 60 degrees, and that's actually going to be one of my answers, right? It's going to be one of my answers, okay? And I'll give you a hint. I'm going to fill in the letters here. Sexy tiger cat. Right? I'm going to fill in the letters. Okay? Where would the other angle be? The angle whose cosine is, hint, positive 1/2. Where is cosine positive? It's positive in this first quadrant. We got the angle there. Where else is cosine positive? In the fourth quadrant, right? In the fourth quadrant. So what I'm going to do, I want to get the fourth quadrant analog of that angle, right? So I'm going to do 360 minus that first answer there. Take the absolute value so you don't get tripped up. Okay? If you want, you can also do 0 minus 60. Actually, no, that won't work, sorry. Never mind. So 360 minus 60 degrees, it's going to be 300 degrees. Okay. So when you figured out what quadrants you need to be in, okay, you were really interested in those numbers on the right, since I'm working on the right side of the coordinate axes. So I do 360, that number on my right, minus my reference angle, okay? If you did 0 minus 60, you would just get your original answer back. Okay, we need another angle, okay? So that's why you have to do 360. And when you're working in the fourth quadrant, you always do 360 minus your reference angle, okay? All right, why can't I circle these as my answers? What do they want? What does the problem want? Radians, yeah, so I have to multiply by what? 180 over pi. All right. Pi over 180, sorry, pi over 180. Going degrees to radians, you multiply by pi over 180, sorry. This is 60 pi over 180, and this is 300 pi over 180. What do these two fractions simplify to? This first one simplifies to what? 60 over 180? Pi over 3. What about 300 pi over 180?
11 pi over 6?
Would it be 5 pi over 3? Should be 5 pi over 3. Yeah. All right. So we found that reference angle, right? We determined what the other quadrant we needed to be in was. We looked at those numbers on the left, or in this case on the right. And we did 360 minus that first answer. okay? Because we were in the fourth quadrant. Okay, any questions? Can I move on to the next one?
What was 10? Would it be 180 minus 60?
Yeah, or we do plus. If we wanted to be in the third quadrant, 180 plus, yeah, right? 180 plus. Cotangent x equals minus pi over 3. What should I do first? I don't like working with cotangents. I should do what? Make it a 1 over tangent. All right, let's solve for tangent. All right, so I need to break that x out of my tangent. What do I hit both sides with to do that? Inverse tangent, yep. So I get x equals inverse tangent of minus 1 over root 3. Okay, this is the angle whose tangent is minus 1 over root 3. Let's go to our triangles. Let's go to our special right triangles. Right? There's no minus root 3 on here, okay? But we do need a reference angle, okay? So which angle here is going to be my reference angle? Which one has a tangent of 1 over root 3?
Wait, this fraction, you know rationalize that?
It's not my final answer, so no, don't rationalize it. That's if it's your final answer that you're going to circle for me, rationalize it. If it's not, just leave it be. Very good distinction. Very good distinction. So which angle here is going to be my reference angle? 30 degrees, right? 30 has a tangent of positive 1 over root 3, right? That's not the same as my negative 1 over root 3, but that's the closest thing. So I'm going to reference that, okay? So ref, let me draw this in red. Reference 30 degrees. A reference 30 degrees. Okay? So, and my 30 degrees is my reference angle, but tangent needs to be negative. What two quadrants up there is tangent negative? S and C, right? So to get this first answer right here, I'm really interested in these numbers on the left. I'm going to do what here? So I have my 180 degrees. I have my 30 degrees. Am I going to subtract them or add them? An angle in the second quadrant here, is that going to be less than 180 or more than 180? So I need to subtract. Okay, take the absolute value so you can't mess up. So that's my first answer. That's my first answer right there. I'm going to convert it to radians later, but for now, that's my first answer. All right. How do I get my answer that's going to be in the fourth quadrant? I need to do what? I think I heard someone say it. 360 minus 30. So I'm in the fourth quadrant. I'm on the right side of my axes. I'm really interested in this number on the left. 360 minus 30. Take the absolute value so you can't mess it up. There we go. Okay, so my final answer, I'm just going to take those 2 degrees. I have 120 degrees. I have 330 degrees. And I'm going to multiply them by pi over 180. Okay, what's 120 pi over 180? What's that going to be? That was a little easier. Oh, is it 150? Sorry. Thank you. Sorry. So what does 150 pi over 180 become?
4/3.
Is it 4/3? Would it be 5/6? 5/6. So 5 pi over 6. So that's my first answer. 330 pi over 180. 11 pi over 6. Yeah. Right. So we need a lot more practice before we can do these kinds of problems on our own, but I think you guys are following what I'm doing. Right? I'm solving for, I'm changing it to something I like working with. I'm solving for that trig function. I'm doing the inverse to break my x out. And then I'm looking at my special right triangles for a reference angle. I'm figuring out what quadrant I need to be in, and I'm either adding or subtracting that reference angle from one of these two numbers, depending on which quadrant I need to be in, okay? Let's do tan x equals 1 real quick. Real quick. Tan x equals 1. So let's break that x out. I'm going to do what on both sides? Inverse tangent. Yep. Inverse tangent. X equals the inverse tangent of 1. So I want the angle whose tangent is 1. Which angle is going to be my reference up here? Which one am I interested in? On my special right triangles, which angle? Yeah. 45 degrees has a tangent of 1. Okay, and that's actually going to be one of my answers. So x equals 45 degrees, also my reference. Okay. Where else is tangent positive here? Where else is tangent positive on this graph? In the t quadrant, right? So what do I need to do to find my answer that's in the t quadrant? 180 plus 45. Yep, and then what do I need to do to get my final answer? Times pi over 180. This is pi over 4. That'll give me 5 pi over 4. Okay, so let's do 4-3 and 4-4. I'm going to collect that tomorrow. Okay, is there a 4-5 homework?
Yeah.
Let's see. 4-3 and 4-4 for tomorrow, for sure. How much is 4-5 there? So let's do 4-5 and 4.5. Let's do 2 and 3. Do 2 and 3.
Thank you.
What's that? Thank you, Maggie.
Back then, you said it like 5 times in a row. You're like, smack that, smack that.
I have no recollection of it.
Yeah, you kept going.
Really? I have no recollection. I just get in a trance. Something takes over.
Wait, you said 2 and 3?
2 and 3, yeah, and 4-5. And then turn 4-3 and 4-4 tomorrow. So we'll definitely finish the notes really early. Yeah, you guys want it today or tomorrow?
What?
Yeah. If you guys want the review sheet now, you can have it. Test is going to be, I'm thinking Tuesday, or I don't see you Tuesday. I'm thinking Wednesday.